Here are the common lens and mirror ray diagrams. Let's start simple. If you have a bunch of parallel rays, I draw parallel rays in red, and you send them to a converging lens, it's going to gather them all at the focal point. But if you give it a diverging lens, it's going to spread the beams out, as if they came from that focal point. If you send parallel beams to a concave mirror, which is converging, it will bring all the beams together. That's what a telescope does, or your satellite dish. And if you have a shiny ball, the light all scatters, as if it came from that focal point. So that's the basics of what happens with parallel beams. If you have a flat mirror, the parallel beam will bounce straight back. And so it looks as if it came from this way. And a beam that hits halfway down will bounce back all the way down. If you extrapolate that backwards, it goes here, and you get a virtual image, which is right side up and the same size. So magnification is +1, positive because it's right side up. Virtual because there's no actual light back there, it's behind a wall. A shiny ball is similar, the convex mirror. The parallel beam bounces off away from the focal point. A beam that points at the center of curvature will bounce straight back, and that would give you this blue beam. And a beam that hits the center of the mirror is flat, so it bounces off at the same angle, and you can backtrack it, and so you get an image here. Whenever you look in a shiny ball, you always see a smaller, upright, virtual image. It's virtual because it's behind the mirror. There's no actual light in there. So the magnification is less than 1, but more than 0, because a negative magnification means it's flipped over. Next case, concave mirror. There are two possibilities for a concave mirror. Either you are closer than the focal point, or you're farther away than the focal point. So first, the closer case. Parallel beam bounces straight through the focal point, just like it did over there. A beam that hits the center of the mirror is going to reflect the same angle. And a beam on the line between the focal point and the tip will actually reflect straight. It's like the reverse of a red beam. Parallel goes to focal point goes to parallel. These beams are not forming a real image because they're not coming together, they're spreading apart. But they look as if they had been together. If you backtrack them, extrapolate, you get a larger, virtual, upright image. That's a makeup mirror. And if you stand far enough away from it, a different thing happens. The parallel beam bounces through the focal point. The beam to the center bounces off at the same angle. And the beam through the focal point goes parallel. So we get an upside down image. Out of all these images, this is the first one that's real, because beams of light really do cross there. So the magnification is a negative number. That's all the mirror cases. Now for lenses. I'll do the diverging lens first because there's only one case. The diverging lens is like the shiny ball. It's going to scatter the light, not gather it. The parallel beam, as we already showed, is going to bend away from the focal point. For a mirror, if you hit the center, it just bounces back like it's flat. For a lens, if you hit the center, you just go through like it's a window. So the center beam, the green beam rather, goes straight through. And this beam's a little tricky. If you aim for that far focal point, you will actually end up going parallel. It's like in reverse. If the beam was incoming parallel, it would bend away from that focal point. So you can see these are all bent apart, but if you backtrack, you get a smaller, upright, virtual image. Yes, there is one beam that goes that way, but most of the beams are in fact extrapolated. You do not get a gathering of beams. For one thing, this is in front of the lens. How could it gather the light if the light hasn't even gotten to it yet? And for another, this lens does not gather light, it spreads it out. So you can't make a real image. Finally, we have the two examples for a convex lens, like a magnifying glass. If you're far enough away, beyond the focal point, it'll be like this case. The parallel beam will go through the focal point. The beam through the center of the lens will go straight like a window. And the beam through the near focal point will bend and go parallel. And you'll end up with an upside down real image. These are the only two real images. But if you're too close, here's what happens instead. Parallel beam goes through focal point. Beam through the center goes straight, and a beam that is coming from the focal point would end up going parallel. So imagine the lens extrapolates up there. And you get an enlarged virtual image. just like that. That's what a magnifying glass does. And those are the 10 basic single lens or mirror diagrams.